time I've ever done that. Sir, okay, so hi everybody, we're doing our fractions finally. Yay for fractions. Now for fractions, I want you to make sure you're thinking of what it actually means, right? Right. And what does it actually mean? Well, we know how to find equivalent fractions. That's on here anyway. Right? 1/3 times 4/4 means, why is it doing that? 1/3 times 4/4 means that we're finding an equivalent fraction, right? 1/3 is equivalent to 4/12. Am I right? Am I right? Am I right?
Yes.
Okay. Why is that? Why do we have to multiply the numerator and the denominator? Because basically we're chopping something up into more pieces, right? Fractions.
Yeah.
Now, why do we need to add with a common denominator? Please stop, ladies.
It's way harder to do.
Well, yeah, because you cannot do it without a common. The common saves those pieces, huh? Yeah, the pieces have to be the same size. So if you keep that in your mind, that should help you to not get lost in all these rules. And then what did we do? When we did multiplying fractions, we thought of a fourth of a fourth, which we all can imagine is a 16th. And remember that rule of multiplying across. So again, if you think about the meanings of this, it's going to help you more than just thinking about any kind of rules. Let me zoom in. Oh, that's so much better for my eyes. Okay, let's hear it for Natalie. She's got all the way from Disneyland. All right, Natalie, how would we do this one? A survey shows that about 9/25, 9/25 of families in a small town do not have resident phone service. Right? It has a decimal.
Oh. You divide 9 by 25?
Okay, that's one way to do it. So 9 divided by 25. Oh, my marker is too big. Okay, how many times is 25 going to 90?
3.
Right, so 0.3. Okay, and then how many?
6.
15, right? And then
6.
what?
6.
I couldn't hear you.
6.
6, isn't it?
Yes.
6. Okay, cool. And so that's the answer. Now, what's another way to do it? I think an easier way. Anybody do it a different way?
No.
Serena?
I multiplied 9/25 times 4.
Exactly. Well, you didn't, I shouldn't say exactly, because you didn't multiply it by 4. You multiply it by what?
4/4.
Good. 4/4, right? Very good. And that way, you can get hundredths. And that's how you get your decimal. Very good. Okay. All right. Any questions about that? Okay. Because we know a fraction bar always means division. Okay, what about number 2?
Same way. Divide 7 by 9.
Same way. But you know what? If it's this easy, I'm not going to make you show your work. Because we should actually just know that if it's ninths is a line over. Okay? What if it said 7/99? Bless you. No. Then what would it be? Does anybody remember? 7/99?
It'd be like
0.07 with a line over both. So it would be 0.707070707. Alright? Okay. Let's hear it for Natalie. Okay, wait, where's my list? Okay, my guest list. Alright, now we got, that's the wrong person. Okay, we got Spider-Man. Coming from the Spider-Verse. Okay, Spider-Man. Well, how do you do number 3?
Alrighty, so, it's rational and real because 2.55 isn't a whole number or, anything like that, so since it's a decimal.
So we're eliminating natural.
Yeah.
Right? Because it's between two numbers, 2 and 3, so it can't be natural. And same as the same thing with whole.
Yeah.
What about integers?
No, because that's not. It's not a negative or a positive, or it's not a negative number.
Well, it's not a negative of one of these.
Yeah.
Positive. Well, integers don't have to be negative, but they have to be, again, same like natural or whole. They have to be without a fraction or a decimal between. So we eliminated that one, and that one.
Yeah.
And everything we do in this class is real.
Yeah.
The only thing that's not real are the imaginary, which you're going to learn
It's
about
also
later. Algebra 2.
It's also rational.
Alright, and yes, how do we know it's rational?
Because because rational includes decimals and fractions.
Yes,
That
exactly.
aren't
Anything
like
that
pi.
can be written as a fraction. So we know that we could write 5500s and reduce that. Right? Okay, so real and rational. Very good. Okay, number 4.
Then
Greater than, less than, or equal to.
it's 2/9 is greater than 2/10 because if you use the butterfly method, 9 times 2 equals 18 and 10 times 2 equals 20. So it makes, and 20 is bigger than 18, so 2/9 is bigger.
That's interesting. I don't know if that word checks. Because I'm not big on the butterfly method. But I know if we write this as a decimal, right? Right? Which one's bigger? 200 or 222, right?
Yeah.
So this one is bigger. Okay?
Clap, 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 clap.
Alright, toothpick is not ready. Where did toothpick go?
This
We gotta
bar
get up to the front though.
turned into a fine red mist.
Alright, so please make sure you're waiting, ready to go. Okay, toothpick is coming all the way from where?
Someone's teeth.
Summons Peak. Let's hear for toothpick. Toothpick.
Yay! Clap, clap, clap.
Okay, 1 gallon of water is equivalent to something. 8.34. Write this value as a mixed number. Oh, that's pretty easy.
That's 8 and 7.
Okay, so 8.30.
Oh, can you stand in front of the computers? Because that's what the mic is.
Oh, okay. So 8.34 is equivalent to 834 over 100.
Right. But usually we would do this step first, right?
Yeah.
And then turn it
You
into
can simplify that into
Okay. Simplify that to what?
to
I know.
8, and you can divide 34 by 2,
Mm-hmm.
and you can divide 100 by 2, and that would
Well, actually, wait. We didn't need to do that part, did we? Because it's asking us for a mixed number. So we can leave the 8 outside. And we just need to reduce 34. Okay, what did you divide it by?
2.
2, so we get
17 over 50.
And we're done, right? Right?
Yeah.
We should write our
Decimal.
units though. Okay. Alright, moving on. Am I going too fast?
Clap, 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 clap.
Okay. Luis typically eats 4.5 ounces of fruit. Good for Luis. Yay.
Lewis. Clap, clap, clap.
Luis or Louise?
I
One
think,
of those.
yeah, it's one of those.
And if it had an E, it would be Louise. Today he ate triple OMG.
Luis
Alright,
eats too much
so-
fruit.
So how do we do it?
So you have to first of all, make 4 1/4 into an improper fraction.
Well, yeah, we're going to do that later, but I would just write it first, the actual problem we're going to do, right? What operation is it? Add, subtract, multiply, or divide.
So we would multiply 4 1/4 by 3 because he's eating triple the usual amount.
Right, and so improper is, what, 17/4?
Yeah.
Okay, 17/4.
And you can also turn 3 into a fraction and make it 3 over 1.
Right. Okay, can we reduce any of these things? No, I don't think so.
No. So 17 times 3 is 51. And 4 times 1 is 4. So you can then make that into a mixed number, and that would be 12 3/4.
12 3/4. Awesome. Well, and again, we should put our units. So it's, how much is it?
Ounces.
Ounces, okay. 12 3/4 ounces. Okay.
That's over a pound of fruit.
I know, that sounds like a lot. That's crazy. All right.
Good for him.
and then we got orange chicken. Where did you come from, orange chicken?
Pan Express.
Where?
Pan Express.
From Panda. Okay. Alright, Panda. Did I just call you a panda?
Yeah.
Well, that's a good thing to be called, right? Pandas are adorable. Okay. Okay. Find the area and the perimeter of a rectangle with a length of 8 feet and a width of 6.5 feet. So it's two different problems, right? They're asking for the area and the
Yeah.
perimeter. Oh, fraction. Perimeter and fractions decimal. Okay. Remember, I didn't get much sleep last night. Did I tell you that? I had a very, very late rehearsal. But I'm okay. All right. 8 feet and 2. Wait, how'd you do it?
I multiplied 8 and 6 and 2 nines.
8 times 6 and 2. Oh, yeah. No, it is. It's 4 things, actually. So it's area and perimeter, and each as fraction and decimal. Okay, so there's 4 answers. Okay, so you're going to multiply first. What are you multiplying for? The area or perimeter?
Area.
Good job. Okay, that's going to be the area. You want to do that first?
Yeah.
Okay, how did you do it?
I turned 6 and 2 ninths into like a improper fraction.
Okay, I think you can do it without doing that, but don't you think?
Maybe.
Yeah, you can. So, 56 over 9?
Yeah.
Okay.
I put a 1 under 8
Yeah, 1 to 8.
and multiply.
And let's see. This can't be reduced, so what's 8 times 56? 448. Okay, thank you. Over 9. Okay, and then we reduce that to. What is it?
49.
49 and
7
7 ninths. Right, 49 and 7 ninths. And that as a decimal is 49.7 with a line over it.
Yeah.
Okay. And then perimeter is easier, huh?
Yeah.
Okay, perimeter is I already put a bunch more room on this, but because it wasn't enough. So 8 and 6, 2 ninths. 8 and 6 and 2 ninths. Okay, how did you find the perimeter?
I multiplied them each by 2 and I added them.
Okay, so 16 and 12 and 4 ninths. Okay.
Yeah.
And then what again?
You add them.
Add them. Okay, cool. So 16 plus 12 is 18 and 4 ninths.
Yeah. That's what
Right? I knew that. Thank you. 28. And then what? Then 28.4 with a line.
Yeah.
Am I right?
Yeah.
Okay, that's a lot of answers for one question. Now, how did he know to multiply these by 2?
Because there's 2 sides.
Because there's 2 sides. So that's right. So this might be now when you have more complicated problems, especially in calculus or something like that, you're going to want to draw a picture. Right? Something like this, you probably don't need to. But anything that's geometry like this, it is a good idea to draw pictures. Did I do this thing wrong? Yeah. That's fine. My marker is too big, but oh well. It's been working okay. I think I had to zoom out even farther. I did zoom out already. But... Okay, now we got this is supposed to be Orange Tree Bulbasaur.
Oh,
Yeah. So Orange Tree Bulbasaur coming from where?
The Game Boy you left in your attic for
Game
2
Boy you left in
decades.
your attic. Okay. That's hilarious. Okay, sir, so Cassandra tap dances for 1 and 7/8 hours a day. Take your time. Today she reduced this time by half. Okay.
So what we do
Mm-hmm.
is that we divide 1 7/8 by 2.
Right, so 1 and 7/8 over 2, which is a complex fraction, or we could just write it sideways. Okay, how do you do that division?
So first, we turn the mixed fraction into a what was it called?
Improper.
Improper fraction, and then
So 15/8.
Yes, 15 eighths. And then we replace the division sign with multiplication.
Mhm.
And then we flip the two ones upside down to make 1/2.
Mhm. All right, I agree. And then we don't have any reducing again.
No
How
cross
come we don't have any
canceling.
reducing in this practice test? I don't know. I didn't write this practice test.
And then
15
that
over 16, is that the answer?
Yes,
Cool. So it's 15/16 of an hour. Okay.
of an hour.
And then wait, you're doing the next one too, right?
Yeah.
Okay. What is the product of these two things? Now, if I were you, I wouldn't turn these into improper. That's a lot more work. Why?
Oh!
I think there's a way to do it. The way to do it is you'd have to do 3 times 5, then 3 times 5 points, then 1/2 times 5, then 1/2 times 5. 5, 6. You have to distribute all of it.
That's a lot better
Yeah,
than
but
how I do it.
Nah, let's do it your way. Okay, so 3 and 1/2 turns into
Let me check. 7 halves.
7 halves.
Negative 7 halves.
Right.
Times 35 6.
35/6. Okay, cool. And then can
Nope.
anything reduce?
No.
Nope. Okay, so
And that equals, according to my calculations, 245 over 12.
right. And that reduces to -20 and
Yeah, it was here. It was here. I forgot to write the negative.
right. So we just have to remember that it's Dorito Man.
Dorito Man.
Go Detail Man!
Okay?
Dotito Man? That's what I heard.
Detail!
Dorito Man. Alright, oh, I get to do this one myself? Yay. Alright.
Yo, Mr. Mayo
Yeah,
Pass!
password. I'm gonna be calling password 1, 2, 3, 4, 5.
Yo,
Alright,
Mayo.
so 1S, so what I'm gonna do is, instead of saying, plug in. You never want to say plug in, Mickey Mouse, but you want to say substitute instead. So we're gonna substitute 4/5 with a parentheses and negative in front. And then 20 was R for 1/4. Negative 1/4. Okay, cool. Alright, so what happens here? 1 times 4/5, well obviously that's 4/5. The bottom we've got 20, oh this is gonna reduce 20 over 1 here. So we divide both of those by 4, and we get 5 over 1. So a negative and a positive though, don't forget. So that would make 5.
Wait, hold on. I'm still writing down all this. I was hoping you'd do this.
Alright. And negative for Dorito Man. And there was a negative in front of the whole thing. So 4/5 divided by 5 is the same thing as 4/5 times 1/5. And actually there was and this was negative and this was negative. So since we had 2 negatives, boy, this is a little tough one, huh? Makes a positive. Positive 4/25. Did I get the right answer? Yep, I got the right answer. 4/25. Yeah.
I was writing down.
Well, it's going to be on the YouTube video and we have to go on. But where it got a little bit squished is there. 20 over 1 times negative 1/4. So if I wrote it out bigger, it'd be a little clearer. 20 over 1 times negative 1/4. See? And then we reduced to 5 over 1. And that's why this is negative 5.
So the answer is negative 5.
No, the denominator there that we're dividing by is negative 5. Yeah, for that one part. And then the final answer is 4/25. Because you got 2 different negatives. So I would go back, but we're going to run out of time. Okay, 11. Zeus.
Yay!
I might want to do it in interest of time, though, just to go fast. Zeus gets lucky. Okay, 4 pieces of wood required. All 4 pieces are cut. How long should the board be So we're gonna do what? Add, subtract, multiply, or divide. Add, subtract, multiply. What? Multiply by what? 4. Okay, so times 4. And we get, we can multiply these separately. So that'd be 40, 56. And 4 times 5 is 26. Which makes, how many is that? 6 going to 20. 3 and 2, 6, 3 and a third. So 56 plus 3 and a third, which makes 59 and a third. So it says in the question, I believe it says, how long should the board be to the nearest whole foot? So the nearest whole foot is 5. Say it again. No. 4 times 4. 4 times 14 is 56. And then 5, 6 times 4 is 20 over 6. So I did them separately. Yeah. Where? Wait, where? It is 59.
That's.
Yeah, this is inches. Alright, so the closest number of feet is 6 feet. Right? I meant 5. Because it becomes 60. Thank you. Thanks, Isaac. Okay, what is this? This is just a definition of additive inverse. They always equal 0. Let's see. I wrote no for the next one. No thanks. You like my little no thanks? Okay. We got what? 14, 15, 16, 17. Oh, we got so many. See how fast I can go. Okay. She gave 2/5 of the licorice to her friend and 2/10 to her sister. Okay. She kept the rest. What fraction did she keep for herself? We're going to add these together. Right? So this becomes 4/10.
Okay, so the answer is no thanks. Wait, we're not doing number 12?
We did number 12. The definition of additive inverse means that if you add 2 together, they make 0. That's the definition.
The answer to 13 is no thanks.
13? Number 3?
Yeah, 13.
You're talking about 13?
3. Number 3. 13.
It's going to be on the, it's rational and real. Okay. 4 plus 2 is 6/10. Alright. Now, if she keeps the rest for herself, how much is left over? Yeah,
2 thirds. No, 2/5.
Right, 2/5. What?
Because that's
We
too
did number
confusing.
12. Times 12 is 0. 13 we skipped. We only skipped 13.
I'll write her name on it.
We did 12. 12 is 0. Okay. Alright. So, this one's 2/5, right? Am I right? Yeah. 14 is 2/5. 4/10 reduces to 2/5. Yeah, Bell is going to ring. Alright. So, okay, so we were a little rushed on this 14. But now that the bell has rung, I can check to see if we need a little more time. Okay, bell. Okay, Juliana bought a container of licorice. She gave, it's bouncing around so much, 2/5 to her friend. There it goes. Okay, she gave away 2/5 and she gave away 2/10. So we're basically subtracting these both from the whole she started with. So we could write the whole equation at once. 1 minus 2/5 plus 2/10. That's how I would write it. So first step is to do what's in parentheses here. We get a common denominator, and yeah, I did want to go back because I didn't have time to write the multiplying the 2/5. So I'm going to go 2/5 times 2 over 2 makes 4/10. Okay, that's how we got the 4/10. Okay. So now that we've multiplied, we've got our common denominator, 4/10 and 2/10. Erasing these arrows. 4/10 and 2/10. I can highlight this though. That's the wrong thing. Okay, 4/10 and 2/10, right? We can add them together and that makes 6/10. But we're not done with the problem yet because they're asking you how much did she keep for herself? How much does she have left after you subtract it from the whole? That's supposed to be an arrow. After you subtract it from the whole. Okay, so last step is, after we have 6/10, we say, how much is 6/10 from a whole? And we again have to have a common denominator actually. So that's 10/10 is a whole minus 6/10. Seemed like everybody in the class yelled this out, so hopefully it won't be too hard for you. Then you reduce. Well, it's a lot of steps, one problem. A lot of steps, one problem. But you can rewind this YouTube video and watch it as many times as you want. Now we have negative 3 5/6 and positive 7 2/3. We cannot, excuse me, we cannot forget about this negative. So, since this is good guys and bad guys, negative 3 and positive 7 and a little bit of change, right? We know that good guys are going to win. We know that these are both different sides of the good guys, bad guys table. So 3 and 7. So we know that good guys are going to win, and we know that we're going to have to subtract. So since we're subtracting, we need to get a common denominator. Now, before we do that, I want to think about it. Now, we can, since we're adding and subtracting, we can do the whole numbers separately from the fractions. However, the problem we're going to run into is that you're going to end up with 4/6 and 5/6. And you're going to have to do 4/6 minus 5/6. And that would mean you're going to have to borrow. And borrowing from the 7 is kind of more trouble than just doing it, changing it to improper in the first place. So I'm going to change it to improper in the first place, but I can do it both ways. But I think this is the better way in this problem. So 3 times 6 is 18. So we've got 18/6, which is the same as 3. Right? 18/6 is the same as 3, plus we also have 5/6 left over. So we got 23/6. That's our improper fraction for that. 7 2/3. If we change that to an improper fraction, we multiply 7 times 3 is 21, plus our extra 2. So we have 21 thirds plus 2/3. I'm just doing 2 separate pieces here. 23 thirds. All right, so there are our improper fractions. Now what do we need to do? Now we need to put our negative back in. What was our negative? This one was negative. So negative 23/6 and positive 23/3. Well, they don't have a common denominator. So let's change this 23 thirds into 6. Meaning we have to multiply by 2 over 2. That way this 3 times 2 will become 6. Okay, so 46. All right, so we've got 46 positive. I'm going to highlight these green. Okay, so we got 46 positive, which this one now will become denominator, and 23 negative. Alright, so now we need a good guys, bad guys with this. This looks like this is a long problem any way you do it. 46 good guys. 46 good guys, 23 bad guys. Good guys win by, we subtract 23. So our answer is positive because good guys win, positive 23 sixths. Can we reduce that? Well, we turn it into a mixed number. Let's see. 6 goes into 23 3 times with 5 sixths. So 3 and 5 6. Okay. So that's the correct answer. So again, we could do it separately. We're just going to have to borrow. So it'll be a little bit different. I'll do it now. You can skip ahead on the YouTube video if you want to see this other method, I would say, this other procedure. So this is the way I would have tried it originally. And then I would have said, no, this is going to be too long. But anyways, we'll do it. Or I'll do it. So I know before I start that I'm going to end up subtracting these two numbers, because if I'm getting the sum, I've got good guys and bad guys. I've got one thing on the bad guy's side, one on the good guy's side. I know I'm going to have to subtract their score to see how much they win by. So I know this is going to be subtraction, and I know the bigger number is this one. This has got 7 holes. So I'm gonna write it like an old school subtraction problem with 7 2/3 on top. So 7 2/3, and we're going to subtract from that 3 5/6. Okay, well, let's change 2/3 to a common denominator first. And that's easier than the improper fractions, I think. So we're going to multiply times 2, right, to get to 6. 2 over 2. So we get 4 6. All right. So I'm going to delete this and go for 4 6 instead. Okay, 7 and 4 6 minus 3 and 5 6. All right, so far so good. But like I said, we can't do 4 minus 5. So we have to borrow, which, I don't know, maybe this way is easier. They're about the same, probably. Now, when we borrow a whole, that's 6 6. Remember? So I'm going to add the 6 I borrowed to the 4. Right, so that makes 10. I'm going to write 10 to make it easier, a little cleaner. Okay, now we can subtract 5 6, and 6 minus 3 is 3. And good guys win. Did I get the same answer? I hope so. Yes, I did. Oh, maybe I take it back. Maybe this way was a little easier. Because I usually try to avoid improper fractions, because they usually make bigger numbers and you have more likelihood of making a mistake. Then I got worried about having to borrow, right? But borrowing wasn't as bad as I thought it was going to be. If you thought you think you may be confused with the 6 6 part, adding here, perhaps, then maybe you would want to do it with improper fractions. All right, that was fun. Well, fun for me. I'm a math teacher, so I like math problems. Okay, 3x minus 12y. Aha. So we're not going to plug in, because you're never going to see plug in on a test. We don't want to use the Mickey Mouse words. We want to use substitute. Okay. So they want substitution here. I'm going to use parentheses for the x. So I'm going to write -2/9. and then minus 12. Y is 4 1/6. All right. This one I'm going to change to improper though. Yeah, definitely. Okay. So, 3 times negative 2/9. Well, why don't I write this as 3 over 1? Write it in the root meter so we can see how it's going to reduce. Times negative 2 over 9. So, 3 and 9 are going to reduce. Divided by 3, we get 1 and 3. So our answer there is negative 2/3. So the first part of it is negative 2/3. Okay, now I'm going to turn this, like I said, to an improper. 4 1/6 is 25/6. 12 over 1 times, and this is negative 12. All right, this is going to reduce as well. So let's get another column here. So divide 12 and 6 by 6, we get 1 and 2. So now our answer to that is negative 50. I like this. This is a fun problem. All right, so first one is negative. Second one is negative. Now we're adding, subtracting, so we need a common denominator. So this problem has multiplication, then addition, subtraction of fractions. Fun. I really like this problem. All right, so I'm going to get a common denominator. So 50 over 1, I'm going to multiply it times 3 over 3. Why? Because we need thirds. 150 thirds. All right. They're both negative. They're both negative. We don't want to lose track of our negatives. Why are they both negatives? Let me go back a little bit. Because the x was negative. The x was negative. So when we substitute x in here, we're doing a positive times a negative, which ends up being negative. Why is the second part negative? The second part, there's no negatives except for this. But that means this whole thing is going to be negative. There's a couple different ways you can look at it, but basically, I would look at it as a negative 12 times a positive 4. You're going to end up with negative. So, therefore, in summary, there, both numbers are negative. So, we've got negative 150 thirds, and negative, well, that's getting a little too close to red, isn't it? Negative 150 thirds and negative 2 thirds. So, how do we combine those? Like this. 150 and 2. And we got 152. And we get, that is not divisible by 3, so it doesn't turn into a whole number, does it? Blue. Alright, bad guys win, remember, so we got, our answer is 152 thirds. We're going to reduce it, of course. So how do we reduce it? How many times is 3 going to 152? Might as well write it the long way to make sure I don't make any mistakes. So that goes in 5 times. And 2 thirds left over. Right? 0. 50 remainder 2, which means 50 and 2 thirds. Okay. So our answer is 50 and 2 thirds. Except bad guys win, so I forgot to write my negative at the end. Don't do that. I wrote a big 1 even, and then forgot to write a negative in the answer. I usually don't do that, but it happens to the best of us. Okay, there's our answer. Let's see, 17, we're almost done. Charlie is making croissants. His recipe calls for 2 3/4 cups of butter. Okay, and he has that much. All right. Explain a method for determining the number of batches of the croissant recipe Charlie can make. All right, so I think I'll just say one method that I would like to use for my number sense. For me, These numbers are going to be a little easier if I multiply it by 2. I'll tell you why. So 2 3/4, I'm gonna multiply it by 2, makes 4 6/4, right? Yeah, it does. So it's gonna be 5 and 1/2. 5 1/2. And then how many times, see it's a lot easier to see how many times 5 1/2 goes into 12 1/2. So that obviously goes in twice because 2 is 11. 2 times 5 1/2 is 11. Why? Because 2 times 5 is 10, and 2 times 1/2 is 1. 10 plus 1 equals 11. I guess I can do that the long way to prove it to you, so if you really want. So 5 1/2 times 2. We're going to turn this into improper, even though I didn't, but you can if you want. 5 times 2 here is 10 plus 1. 11 halves times 2. Oh, here you could just reduce. 11 over 1. Okay? So, we found that if we have 12 1/2 cups of butter, we can do 4 batches. Why do I say 4? Because we multiply by 2 to get 5 1/2. And 2 of those, that's 2 times 2, is 4 batches. Now, am I sure that we can't do another one? Yeah, because I know if I add 2 3/4 more cups to 11, that's going to be way over this. Okay, so our answer is 4. Let's see about B. If Charlie plans to make 5 batches, you're going to predict the amount of butter. Okay, so let's see. When they say predict, I'm thinking they mean exactly in fractions, not how much he's buying at the store. Okay, I don't know what denominations they come in at the store. So let's see. So they're just asking for 2 3/4 times 5. That's all they're asking for. We already know though that 11 is 4, so I'm just going to add that. 11 plus 2 3/4. Or we can do the times 5 too. 11 plus 2 3/4. Okay. So 13 3/4, which is your answer, cups. However, we can also do multiplication. So 2 3/4 times 5. All right, so multiply that and that separately. The reason it didn't work earlier in our practice test is because the other time we tried multiplying separately was when it was like this, when there was an extra fraction here. If there's an extra fraction here, then you would need to multiply all 4 together. But now, since there's only 1 here on the second side, we can get away with this, which I think is easier. Sometimes it's good for mathematicians to look for shortcuts. Usually you want to show your work, but sometimes shortcuts are better. Sometimes. So 5 times 2 is 10. 5 times 3 is 15. So it's 10 15/4, which makes same thing. What is 15/4 reduced to? 15/4 is reduced to 3 3/4. So 10 plus 3, 10 plus 3 3/4. And then we get 13 3/4. All right, we are done. That was fun. Except, what happened? Did I lose it? Yeah. 13 3/4. Don't forget to write your units. Yay! Have fun studying.